Hello, welcome to this lesson. In this lesson, we're going to be talking about linear regression. We're going to be looking at data sets displayed on a scatter plot. We're going to see that the scatter plot follows a linear relationship. Our goal is to find in line the models, or the best models, the scatter plot that we have. Okay? In other words, we're finding in line the best models, the data set. Let's go ahead and read our learning objectives. First, we're going to focus on being able to find the regression line, and we're going to be using technology for this. You're going to be using your calculator. You can also use Google Sheets and Excel. Once you have the regression line, you're going to use the regression line to make predictions. Okay? So in this lesson, you're going to learn how to make predictions using a regression line for a data set. Your last learn objective is to be able to interpret the slope of the regression line, the intercepts, so the x and the y-intercept, and any given point on the regression line. Let's start by highlighting the main questions that we're going to be asking ourselves when we talk about regression lines. We're going to examine data from two variables, and we're going to ask ourselves, is there a linear relationship between these two variables? And we're also going to ask ourselves, can we create a linear function to model the data set? Another question that we're going to be asking ourselves is, how strong is the linear relationship? To answer this question, we need to look at what we call the correlation coefficient. We're not going to get to answer this question in this lesson. Okay? That is coming up in our next lesson. In this lesson, we're going to focus on regression, which is the process of finding the line that best fits the data. Now, before we try to find the regression line for a data set, we're going to do a little warm-up. I'm going to give you three different scenarios, and you're going to identify the explanatory variable and the response variable. In order to find the regression line for a data set, we need to create a scatter plot. And for that, we need to decide what variable is going to go on the horizontal axis, also known as the x-axis, and we need to decide what variable is going to go on the vertical axis, also known as the y-axis. Earlier this quarter, you learned how to create scatter plots, and you learned that we always use the x-axis to display the explanatory variable. We also learned that on the y-axis, we display the response variable. This is the reason why I want to do this warm-up. I want to make sure we practice identifying the explanatory variable and the response variable. That is going to help us create a scatter plot. Once we have the scatter plot and we verify that we do have a linear relationship, then we're going to be creating a linear function that models the relationship. Let's consider part A. A teacher wants to determine if there's a relationship between high school GPAs and SAT scores. The teacher aims to predict SAT scores using the high school GPAs. So think about it. The teacher is going to have access to high school GPAs. Using the GPAs, the teacher is going to try to predict the SAT scores. You can think of this as the SAT scores are going to depend on the high school GPA. So here, the explanatory variable is going to be the high school GPA. The response variable is going to be the SAT score. We can go and randomly select high school students. We can look at their high school GPA and their SAT scores. We can come up with a scatter plot, and we can see if that scatter plot is going to follow a linear pattern. If we see that the scatter plot follows a linear pattern, we can go ahead and find the regression line that models that linear pattern. Here, our x values are going to be the high school GPAs. Our y values are going to be the SAT scores. Okay. Now, in part B, you have another scenario. Let's go ahead and read the scenario. A dietitian wants to investigate if there's a positive relationship between alcohol content and the number of calories in 12-ounce beers. The dietitian aims to predict the number of calories in 12-ounce beer based on the alcohol content. The dietitian has access to the alcohol content. Dietitian is going to use the alcohol content to try to predict the number of calories in a 12-ounce beer. So here, the alcohol content is going to help us predict the number of calories. In this case, the explanatory variable is going to be the alcohol content. The response variable is going to be the number of calories. In this case, we would randomly select 12-ounce beers. We would keep track of the alcohol content on each of those beers and the number of calories on each of those beers. With that information, we would go ahead and create a scatter plot. If we see that the scatter plot displays a linear relationship, we can use technology to find the line that best models the scatter plot, or the best models this linear relationship. And then we could use the equation of that line to make predictions, such as if I know that a 12-ounce beer has 5% alcohol content, can I predict how many calories that beer is going to have? So again, your X values would be the alcohol content of beer. Your Y values are going to be the number of calories. Now again, let me emphasize how we would have to go and collect data. I don't know if these two variables have a linear relationship. Okay? We would need to go out there, randomly select a sample of 12-ounce beer. We would measure both variables. We would create a scatter plot, and we would ask ourselves, do we see a linear pattern on the scatter plot? If we do see the linear pattern, then that is when we use technology to find the linear model. But again, you first need to verify whether the variables have a linear relationship. Now, I'm going to let you do part C on your own. Here, you're being asked to identify the explanatory variable and the response variable.